What's up, guys? In the last class, we have learned about what is exactly a derivative is and what is the concept of derivative, right? And we have also seen about the derivative of first principle, which is nothing but a definition of a derivative, right? In this class, we are going to see about what are the derivatives of a standard functions and what are some of the rules for differentiation. And most probably, this is one of the most important class because you need to really memorize this the derivative of a standard function. You just need to know the derivative of a standard function. As you belong to the commerce background, so you don't really have the derivation of this the standard function. For example, derivative of x is 1, and derivative of x comes as 1 by using the first principle formula. As you are from a commerce background in your HSC, you don't have to derive this, right? You have been given that the derivative of x is 1. But if you are from a science background, it actually starts with solving the derivative using the first principle, right? So you have been given and you need to know this, and this forms the base of all the exercises which you are going to do, and you need to know this by heart. So I'm going to walk you through. This is called as a derivative of a standard function. Note that here y is a function of x. So you have been given that y is a function of x, and at the right hand column, dy by dx, right? So basically derivative of y with respect to x, and it is also written as f dash of x, right? Or f prime of x. Some people pronounce it as f prime of x or f dash of x. So at the left hand column, you have a function of x, and at the right hand column, you have a derivative, right? So the first derivative of a k, right? And k is nothing but a constant. For example, 1, 2, 3, all numbers, right? These are constant. And the derivative of a constant is 0. Note that the derivative of a constant is 0. You need to remember this. Similarly, derivative of x is 1, right? For example, you have been given y is equals to x, then dy by dx is equals to, you know, 1. Or let's say that you have been given y is equals to 2x, then dy by dx is equals to 2 will come outside, then d by dx of x, which is nothing but 2, right? 2 into 1, which will come as an answer as 2, right? So derivative of x is 1. Similarly, derivative of x raised to n, right? Derivative of x raised to n is given as n into x raised to n minus 1. This can be of the form, let's say that y is equals to x raised to 8. So derivative of y with respect to x will be given as 8. Notice that here 8 is nothing but an n. So 8 into x raised to n minus 1, which is 8 minus 1, and the answer will be 8 into x raised to 7. This is your derivative of y with respect to x by using the x raised to n formula, right? You have been you have this. Similarly, derivative of 1 over x or 1 upon x is given as minus 1 upon x squared. For example, y is equals to 3 upon x, and if you find the derivative, right, dy by dx, so 3 into d by dx, as 3 is a constant, I'll move 3 outside. So d by dx of 1 over x, and the answer will be minus 3 upon x squared, as the derivative of 1 upon x is given as minus 1 upon x squared, so minus 3 upon x squared, right? Similarly, derivative of a raised to x, notice that a is greater than 0. Also, a should not be equal to 1. Then the derivative of such a form is given as a raised to x into log a, right? So let me go through some example here. So for example, derivative, let's say that y is equals to 2 raised to x. Here, remember that a is a constant and a is greater than 0 and a is not equals to 1. So y is equals to 2 raised to x. Then dy by dx is given as a raised to x. In this case, a is equals to 2. So 2 raised to x into log 2, right? So this is what the a raised to x looks like. Also, derivative of e raised to x is e raised to x. So this is quite simple, right? So derivative of e raised to x is e raised to x. Also, derivative of log x is 1 upon x, right? You need to remember this derivative of some constant function, because this is very important, very, very important, right? So you have this table and you can write it on your notebook, and you can also find in your textbook at page number, you can find this at the first page itself of the differentiation, right? You just need to go through this table, because when you solve the problems related to the differentiation, you need to know this, right? Because this forms the base of everything. Okay, let's move to the new page, because we are going to see about few rules of differentiation. So I'm going to write rules of differentiation. Differentiation. So what is the first rule of differentiation? Let's say that y is equals to u plus minus v, right? Y is equals to u plus minus v, then dy by dx is given as du by dx plus minus dv by dx. So this is like, let's say that y is equals to u plus v. So basically u and v are a differentiable function of x. Then the dy by dx is given as du by dx plus dv by dx, right? Similarly, y is equals to u minus v, then dy by dx is du by dx minus dv by dx. So this is your first rule of differentiation, right? Where u and v are a differentiable function of x, right? So I'm going to write here u comma v are a differentiable function of x, right? This is the first rule. The second rule states that y is u into v. So basically it is a multiplication of u into v. Then dy by dx is given as u into dv by dx plus v into du by dx, right? So if y is equals to u into v, then dy by dx is equals to u into derivative of v with respect to x plus v into derivative of u with respect to x. So for example, this could be like y is equals to e raised to x into log x. So this is your u, the first term is your u, and the second term is your v. And if you find the derivative, you just need to use this formula. So this would be like e raised to x into derivative of log x. We have seen in the previous slide, derivative of log x is 1 upon x plus v, in this case log x, into derivative of u, which is e raised to x, which e raised to x, right? So this is your differentiation of u into v. The third rule states that if y is equals to u upon v, then dy by dx is equals to v into du by dx minus u into dv by dx upon v square. Just notice that here v should not be equals to 0. Why? Because if v becomes 0, so anything divided by 0 is an undefined in mathematics, or indeterminate. It is called as indeterminate. So let's say that y is given as u upon v, division of u upon v, then dy by dx is equals to v, this is v into du by dx minus u into dv by dx upon v square, right? This can be like y is equals to, let's say, e raised to x upon log x. you just need to use this formula and you'll get your answer, dy by dx, right? The last fourth rule is y is given as k into u, then then dy by dx, is given as k into du by dx, where where the k is a constant, where k is a constant, right? So let's say that y is of the form 3 into e raised to x, 3 into e raised to x, then dy by dx, 3 will be outside because 3 is a constant, into du by dx. In this case, u is e raised to x, so 3 into d by dx of e raised to x, we will get the answer as 3 e raised to x because derivative of e raised to x is e raised to x, right? So let me solve this, right? So this is of the form y is equals to 3 into e raised to x, and if you find dy by dx, then it will be k into du by dx, which is d by dx of e raised to x, and e raised to x, differentiation of e raised to x with respect to x is e raised to x only. So the answer will be 3 e raised to x. So this is very easy. You have these four rules of differentiation. You need to first by heart the derivatives of some of the standard function and these rules of differentiation, because we are going to use a lot of these rules and the derivative of standard function while solving the problems, right? So these are the four rules. The first one is subtraction and addition. The second one is multiplication, right? Third one is division, and the last is of the form constant into some function, right? Constant into some function. So just write this in your notebook and just by heart this, right? Or there is no need to by heart, guys. You just need to understand that the pattern here, right? So this is very easy. From the next class, we are going to see what is a composite function, and then we are going to solve the derivative of a composite function, right? So exercise 3.1 deals with the chain rule and finding the derivative of a composite function using the chain rule, obviously. So I'll catch you up in the next class. Till then, goodbye and see you.